Hello, good morning, good afternoon, everyone. Welcome to this new webinar presented by AFRINIC. The title is Implement a Dual Stack DNS Infrastructure. So this webinar is presented by Willy Manga with all the team of the capacity building. So let's start from the chat section. If you can, please give us your location and also say if you are able to hear us. In the chat section, you can tell us your location and also if you are able to hear us. Good. Grahamstone from Yemen, Pretoria, Madagascar, Malawi, Sudan, Burkina Faso, Cape Town. Edouard from Malawi. Good morning, good afternoon. Oh, okay. So I guess everybody is able to hear me. Good, good, very good. Okay, so we can proceed. So we'll use a tool called Menti. If you can go to menti.com, there is a question for you. So go on menti.com and type the code you see on the screen. Menti.com, code 702747. The question is, strictly speaking of a dual stack DNS infrastructure, which elements are relevant? The code is 702747. Strictly speaking of a dual stack DNS infrastructure, mentions elements which are relevant. Authoritative servers, IPv6 routing policy, resolver, advertising your IPv6 prefix, zone files, or enable IPv6 in the core network. When we talk about the DNS infrastructure, for you, what is the most relevant? So far, only 7 people, 8 people. So I repeat, the code is, you go on menti.com, www.menti.com, and use the code 702747. 15, 16, good. 20 people, at least 50% of the participants so far. Strictly speaking of a dual stack DNS infrastructure, mentions elements which are relevant. Okay. Can we have more people? 24, 26. Okay, we can proceed. I'll just show you the answer. We have 30 people. This is good. Okay. So the answer is, speaking of DNS, the most important are the resolver, the zone files, and the authoritative servers. So for this presentation, we'll have some assumptions. We assume that we have an IPv4 network working. IPv6 is enabled and we have a dedicated IPv6 prefix routed. and we maintain some zone, a forward zone called cmnog.cm and a reverse zone for IPv6. We have two resolvers running, one running unbound and the other one running bind. And we have one authoritative server running on bind. So as objective, we assume that you will be able to understand the purpose of each component, understand what is the purpose also of the resolvers and the authoritative servers, analyze the requirements for a dual stack implementation of your DNS infrastructure, and also create relevant domain object for your resource in myafrinic.net. So we have a typical network for this presentation. Usually we have some components. The most important, we'll start by the recursive cache server. Then we'll also talk about the authoritative and the slave servers. And the last part will be related to what we have here, which is the zone files usually stored on one authoritative servers. So which components are involved here? We have the resolver, authoritative servers, the zone files, and the slave servers. Let's start by the resolvers. For the resolvers, we'll try to configure a dual stack resolver. And like mentioned in this diagram, the resolver is usually located in somewhere in your network. It's close to your client and also connected to one or two servers and connected to various networks. Remember that we are in a network where IPv6 is already enabled. Our recursive server is already able to reach the internet over IPv6. Before we proceed, another question for you. Which resolvers do you know? Go on menti.com, same code. Which resolvers do you know? So you go on menti.com and you use the code 702747. Which resolvers do you know? We use the resolver to have an answer. Let's say we know a name and we want the number. So we use the resolver for that purpose. Which resolvers do you know? Two people, 4, 5. So I repeat, you go on menti.com and you type the code 702747. And the question is, which resolvers do you know? 12 replies so far. 15 replies. We are more than 40. So I guess we can reach at least half of the people. 56 people. The question is, which resolvers do you know? Where are the others? 20 people so far. Okay. So based on your replies, we can tell that most of you you know one resolver called bind, okay? Another one called unbound, Google, Yes, power DNS, also not DNS. Root server. The root server are not resolvers. The root server are not resolver. Okay. So from your replies, the more specific, the more accurate answers are bind and bound, not DNS, and power DNS also. ISC is the one who built bind. So the answer here will be bind. DNS mask, yes, it's a kind of stub resolver. Okay, let's proceed. So for your resolver, when you want to enable IPv6 in your resolver, first step for you will be to assign an IPv6 address to your resolver. Second thing will be to update your config file. And by updating your config file, I mean you have to make sure that your resolver is able to listen on IPv6. Then you also have to update the access list related to the resolver to allow only prefixes which are allowed to request recursion. Because when you have a resolver in your network, usually when it's not an open resolver, you only allow your internal network or your customers to query your resolver. So most of you who manage already a resolver on IPv4, in IPv6, the principle is the same. So you have to add also the prefix, your IPv6 prefix of your internal network or your customers into this access list. Also, last one will be to update your firewall rules. Basically, the purpose is to allow outbound on port 53 on UDP and TCP. UDP and TCP, this is very important. Let's have a little configuration of one resolver on unbound. With unbound, unbound is a lightweight resolver. Basically, you have to, from the default config file, you copy it into the configuration file, into configuration section, and then you have to update the interface that you'll be using. You have one in this example in IPv4. And in this example, we have two in IPv6. We have the localhost colon 1, which enables your own servers to also query itself over IPv6. And you have the other one in which enable the network to query your resolver over IPv6. And then after that, you will also have the access control, where you enable your entire network to query this resolver over IPv6. So in Unbound, that's pretty much what you have to do to enable IPv6 into your resolver. Let's see also for bind. For bind, remember that those who know already bind can do two things. Bind is at the same time a resolver and also an authoritative server. We mentioned earlier Unbound because Unbound can just do the resolver stuff. So usually when you are not involved in a zone file management, we advise you to use only a tool like Unbound where you can just use a resolver. So now let's look at bind 9. With bind 9, you have to, in your config file, which is name.conf.local usually, depending on what you are doing, you have to, you'll create an ACL for your network, depending on your network. Here we have an ACL where we put the localhost colon 1 and our network. And you will create a view. This view is pretty much the same also in IPv4. you see in this view, I had my ACL, and also I include some default zone here. And of course, with bind, you also have to make sure that you are able to listen on IPv6. That's why we have another section for this. Okay, before we proceed, any questions? Okay, let's continue. We have the question after. Now we continue with the DNS server. Remember, we were talking about the resolver. Now, after the resolver, the next step for you, for those who have an authoritative server, will be to see what you have to do. Remember that we are at this level right now. We are trying to see what we have to do to enable IPv6 into our authoritative servers. So for your authoritative server, usually the steps are, you also have to assign an IPv6 address according to your IPAM. You have to update your config file. And then obviously you have to listen on IPv6. And now for each zone file that you manage, you have to allow the relevant network to query it. Remember that you have a zone file. Let's say we are talking about cmnog.cm. So it means for each zone file you have, you should allow the entire internet to query this zone because this one is public. So in your config file, you'll have something which is very generic for the whole internet. But if you have a specific zone file, maybe you use it internally, then in your access list, you'll only allow your internal prefix. After that, you also have to allow the zone transfer over IPv6 because remember that when you have a zone file, usually you have at least 1 or 2 slaves. Then you also have to allow the zone transfer over IPv6, such a way that your authoritative server is able to send the response over IPv4, but also in IPv6. Then for your firewall rules, you have to allow the outbound and inbound because your authoritative server need to query the internet. And also remember that from the internet, we should be able to reach your DNS server over your port 53. Let's have a quick look on bind9. With bind9, usually you have your ACL where you put the name of your slave. In this example, we have the ACL with the name of the IPv4 of the slave and also its IPv6. You have your view. In your view, you'll include the default zone. The match clients, this is where you'll allow the entire internet to be able to query your DNS servers, and then you configure your different zone files. In this example, you have two. One called for forward DNS for forward zone, cmnog.cm, and another one for the reverse zone over IPv6. So this is what you have with using bind. And also, don't forget to ensure that your bind server is listening on IPv6. For your slave server, the configuration is pretty much the same. The most important here is to allow the zone transfer from master over IPv6. Because remember that your master will send updates of the zone. Each time you do an update, you modify something in your zone file, the master will send announcement at the updates over the internet to the slave servers. So you have to make sure that in your slave, you have a configuration which enable you to receive these updates. And again, the firewall rules will be the same. So for the bind servers, almost the same also. Here, the main difference will be in the zone file, you see we have a type called type slave instead of master. Let's go into the zone files where we need to add the required resource records. This time, according to our diagram, we are working here. We are working on some files stored into our servers. Which components are involved here? We have the forward zone, the reverse zone. We have to do a kind of delegation or a reverse delegation. So forward and reverse. Remember that when we are talking about the forward zone, it means we have a name and we want to know the number, or it can be another name. Like here, at the bottom you see, we have this name, 3w.cmnoc.cm, and we want to know which is the equivalent in IPv6, for example. For the reverse now, the reverse zone, we have the number, and we want to know the name, the fully qualified domain name, which is we have this number, and we want to know the equivalent or to which name is attached this number. That's the purpose of the reverse. Okay, before we continue, another question for you. What is the purpose of the glue records? Those who are master of the DNS. Can you tell me what is the purpose of the glue records? What is the purpose of the glue record in DNS? Is it to map name and numbers in the zone file? Is it to link a zone with its subdomain? Is it to stick two entries in the zone file? What is the purpose of the glue record? Okay, maybe it was too fast. Only 9 people replies and only 3 find the answer. The purpose of the glue record is to link a zone with its subdomain. We'll see it in the presentation. Okay, let's talk first of the forward zone. On your left, you have an example of forward zone. Usually in the forward zone, we can call this one the header, okay? And here we have, in the header, we have the name of the server of authority, and we have some setting related to the cache. And then you have some lines for the name servers, which indicate which are the name servers for this zone file. We have the mail exchanger, which indicates which is the SMTP server of this zone. And now in IPv6, for resource records in IPv6, you have some entries like this one. You will have some entries like the 2 lines we have here with quad A records. So I guess most of you identified that the zone file in it's not very different from what you already know when you use only v4 resources. So you have for v6, usually you'll have only a resource when you have a server or a machine running. Do not have a resource record here when you are not running already IPv6 on a particular machine. We also talk about the glue records. In this example, we have some glue records at the bottom here. And we'll try to identify exactly. But remember that in this example, this zone file is for cmnog.cm, okay? And the glue records is used to link from the parent zone. From the parent zone, we'll be able to know exactly who are the name server who can give the answer for a particular subdomain. So let's say I'm the manager of the cmnog.cm zone file. In order for the internet to know that when you want to know what are the entries for my zone files, the first thing will be for you to go at the root level. You go at the root level, and from the root level, you reach the servers of the CM. And from the CM, you'll be able to reach the cmnog zone file. But how is it possible from CM to link to my zone file? It's because we'll have in the CM zone file a glue record like this one. Here we are in the CM, it's just an example. In the CM zone file, the administrator, the manager of the CM zone file will have 3 entries. 1 entry, the first one for the name of the server. We want to manage cmnog, and the name of the server is ns1.cmnog. Now we'll add its IPv4 address. Then we'll add its IPv6 address. Remember that we are in the CM zone file, not in the zone file that you manage. It's these 3 entries which links the parent zone to your zone file. And you see, if we want to query your zone file also in IPv6, we need the last entry, the quad A record of your name server in IPv6. So I go back quickly to our zone file. Then from our parent zone, now we are able to reach our own zone. Now let's say we have a subdomain in our own zone. This subdomain is called in our example dev.cmnog.cm. Then same exercise. Now from my zone file, I will add the name of the name server of this zone file. In this example, it's ns2. And I will also add its IPv4 address and IPv6 address. So you see, it's exactly the same exercise. Okay, let's proceed. For the reverse zone, before we continue, I invite you to take a deep breath, and yes, because for the reverse zone, we'll have to take more time. Do you have some questions? Please, if you have some questions, just drop them on the Q&A sections. Then we'll be able to answer all your questions either during the presentation or at the end of the presentation. Bob? Bob, do you have any question? Send your question to Q&A, please. Olaposi, if you have a question, please send it to the Q&A section. Okay, we'll continue first. We'll be able to answer all your questions at the end. So either you send your question to the Q&A or you just wait before the end of the session. You'll be able to ask directly your question.
Okay. For each subdomain, should I create a new glue record in the same file? So say COSI.
Yes, Kosi, for your question, yes, exactly. For each of your subdomain, let's say you manage, it can be you manage the subdomain or it can be another person. So each time you'll create this glue record because this is how you do the delegation for your subdomain. Because remember that in the same way you are able to manage a particular zone, your parent zone did the same. Let's say you have AFRINIC.net. You are managing AFRINIC.net zone file. One of the administrator of the .net zone file have inserted into this zone file at least 2 entries, 2 resource records. Usually, sometimes it will be 3. The first one is the name server for AFRINIC, and the 2 other rows will be for the IPv4 of this name server and the IPv6 of this name server. So each time you have some subdomain, you will add the glue records. Remember that also the glue records help you to manage more easily, because if it was you who will have to manage all the resource record for every zone file that you have, this would be very difficult. Imagine one moment that you were the manager of the .com zone file, and it will be the manager of the .com zone file who should insert into the subdomain each entry that we have currently for the .com. This is not manageable. Okay, we'll continue and we'll take the other question later. Okay, so now for the reverse zone. First steps for the reverse zone for you is to identify the relevant IPv6 block. Where did you get this IPv6 block? From your IPAM. And from your IPAM. And who is able to manage it? It will be your DNS manager. So first step, you identify the relevant IPv6 block that you want to use. Let's say we want to use this one. For instance, we pick it from our IPAM. Now, second step is to register assignments. What we want to do is to have our end-site assignment done, and we have to log into my afrinic.net. And who is able to do this task? It will be the manager of the selected IP block. The manager can be either yourself as an end user who has an account on my AFRINIC and you have your own resource, or it can be your internet service provider or either your cloud provider. Because remember that we are talking about numbers. And now, who is the manager of these numbers? Sometimes it's not the customer. Sometimes it can be the ISP, internet service provider, or your cloud provider. So the person who manages the IP block will have to go into myafrinic.net, and then you have to do what we call an end-site assignment. After this task, the last one related to myAfrinic will be to add a reverse delegation. And the reverse delegation is the last step from myAfrinic that you have to do. When this task is done, you'll have what we call a domain object created into the whois database of Afrinic. So I repeat, first step, identify the relevant IPv6 block. Second one, register assignments. You do that from your myAfrinic. The third one will be to add the reverse delegation. So you have details on myAfrinic. I was saying you have to log into myAfrinic. You go into your IPv6 resource, and you notice a section here where you do add end-site assignment. You'll add your end-site assignment from here. So this is only for those who have an account and who manage the IP block. Now you can prepare your reverse zone file. Let's do that. So for your reverse zone file, it's almost the same with just little difference with IPv4. In IPv6, we have a zone, the zone called IP6. The top level here is IP6.ARPA. And then you put your prefix block. And in this example, we have a shortcut. We use a variable called origin. So it helps us to shorten the resource record, because using this variable, we are not obliged to write all the number below. For example, remember that we are managing this prefix, this one. Okay, so it's a /32 in IPv6. And here we had one particular example, one host. This is its IPv6 address. And we want, in the reverse zone file, we have the resource records are called the PTR. So what you do is you add this address in the reverse way, okay? So it's the same address written in reverse. That's why we call it the reverse zone file. So we have this address and we have the reverse. Same example at the bottom here. We have this address and we have the reverse. Okay. So this is a sample of what we can have in your reverse zone file. But what do we need? Why do we need to manage the reverse zone? I think for some of you, it looks very difficult, or you don't see the needs of the reverse zone file. The IP numbers of your SMTP server should return an answer. This is critical, because when you have an SMTP server, be it on IPv4 or IPv6, the whole internet should be able first to, let's say, know from smtp.cmnog for instance, .cm, it's IP block in IPv6, for example. This is for the forward. But also, very critical, from this IPv6, we should be able to have this name. Okay? We should be able to know from the IPv6 number that we see, we should find the equivalent, the name associated to this number. So this is one of the most important feature or needs for a reverse zone file. If you want your SMTP server works on IPv6, the first thing to do is to make sure that you have allocated your block, assign it, and then in your reverse zone file, at least one resource record dedicated to your SMTP server should be here. At least. This is the most important resource record that you should have in your reverse zone file, be it on IPv4 or on IPv6. Also, you want to know which host is behind some numbers. I will take just an example. You manage your core network. You have IPv6 interface, point-to-point interface over IPv6. And you want to know, oh, this is my IPv6 address for one point-to-point link, for example. And you want to know from this address, what is the name? What is the name behind this number? You manage all your IPv6 address, but you don't know what is the name. So you have the name because you will insert it into the reverse zone file. Yes, question?
When using origin is it important to set the IPv6 to capital case?
No, it's not important. It's not case sensitive. So you can write it either on small letters or capital letters.
That was a question from Kosi. Another question, how does one run a whois query for the NSs hosting a reverse delegation from your AFRINIC whois site?
Okay, we'll see it at the end of the presentation. Kosi will answer to your question at the end because we'll have some practical, just a short practical session.
So this is a question from YouTube. So the CM file will be configured by my ccTLD admin. They will point the NS data to my zone file, right?
Yes, the CM file, like all parent zone file, will have to insert the data related to your name server. So usually there is an interface depending on how the manager of this zone file used to do. Maybe there is an interface or it can be manually. It depends on how the manager of the zone file used to work. But this is the link between the parent zone and your zone, because if this link does not exist, the internet is not able to query your zone file. And remember also that for the reverse one, the link comes from AFRINIC or your IRR. But for the domain name, the link comes from, let's say, your top level domain or your country code top level domain. So the number, the link is established with your IRR. And for the name, the link is established with either your top level domain or your country code top level domain. But they are all linked to the root servers also. Okay, now some tools. Just a quick presentation of 3 tools, 2 command line tools and 1 online tool. The first one is Dig, which is a command line tool. Using Dig, you can query either a domain name or a number. So you can query either a domain name or a number with Dig. The second tool is zipcalc. With zipcalc, you can do easily the reverse, but there are a lot of functions that you have with zipcalc. But I just pick one, which is related to the reverse, using this parameter, -r. Using -r, when you type your IPv6 address, you can have the reverse one. Is very easy. So don't worry, don't be afraid of IPv6, guys. zipcalc is here for you. Now, the last tool is an online tool, zonemaster.net. With zonemaster.net, you can insert your domain name and check if you are good in terms of best current practice, either for your forward zone or for your reverse zone. So you have these 3 tools, but obviously you have many tools on the internet. You can find them. There are many websites where you can find all these features, but at least these 3 tools are very, very useful, and you can find it into many operating systems. So yes, just a quick recap, just some blocks for you. When you want to have a dual stack infrastructure in DNS, the first thing, the most obvious for each kind of user will be to have IPv6 for your resolver. Okay? You can be an ISP, a cloud provider, or a corporate user. The first thing is to enable IPv6 on your resolver. That's the first thing. As soon as you have already an IPv6 network, or IPv6 is able to reach your network or your resolver, then this one is the first thing to do. Now, when you are not just an end user, but you are either an ISP, corporate user or cloud provider, now you can do various stuff. You can enable IPv6 on your authoritative servers, on your slave servers. You can hide the resource record in the zone file. Some tasks are not linked because you can do some tasks before doing, let's take an example. You can have in a zone file resource record related to IPv6 without enable IPv6 into your authoritative servers. So it depends on the context. So you can create you can have glue records over IPv6 for all your subdomain. This one is very important if you want to enable your user or your customers to use or to query their own domain over IPv6. Okay, last quiz. Last quiz. To be sure that all of you are following. The question is here. I want to map all my IPv6 point-to-point link to correct host name. Which zone file should I use? I want to map all my IPv6 point-to-point links to correct host name. Which zone file should I use? Forward zone, mapping 6 zone, reverse zone. Okay, reverse zone. Okay, 8 people find the right answer. Next question. Oh, Nicolas is doing well. Next question. Get ready. What can be the output of dig plus short quad A record 3w.cmnog.cm? Oh, it's very small. Okay, the first one is an IPv6 address. The second one is the reverse. The third answer is none. And the fourth is an IPv4 address. So what can be the output? Good. It can be either the IPv6 address, or it can be none. None because maybe this resource record does not have an IPv6 equivalent. Get ready. My line is currently using IPv4 only. Our resolver is already on IPv6. Can we get quad A records if we query the resolver? Yes or no? Are we able to query our resolver and get quad A records related to IPv6? Yes, you are right. You are right. Last question. Which of the following are .arpa subdomains? Which of the following are .arpa subdomains? ICANN, in-addr, IP4, IP6, IANA. Which of the following are .arpa subdomains? IP4, IP6, IANA. Okay. Oh, most of you found the answer related to IPv4, which is in-addr, but you also have IP6. Remember that during this presentation, we were talking about the reverse zone for IPv6 number. So it will be your IPv6 address in the reverse .ip6.arpa. Okay, if you have questions.
Yeah, thank you really for that presentation. Guys, if you have questions, you can either raise your hand, we'll give you the microphone, or just go ahead and type your question in the Q&A session. Some of the questions were answered already, waiting for some more. So Willie, you have this question. How does one run whois query for the NSC's hosting a reverse delegation from your AFRINIC whois site? It's from Anonymous.
How does one
run a whois query for the NSC's hosting a reverse delegation from your AFRINIC whois site?
Okay, I'm not sure to get the correct answer for you. But usually when you want to query the reverse, you use if you use the command line, you have the parameter -d that you use. So you have, I will just write it in the screen. So you have something like this. whois .afrinic -d my IPv6 address, like this. Okay, so this parameter helps you to find the domain object related to, or the more specific domain object that you can have related to this IPv6 block.
Okay, thank you. Is it, this is from Gordon Grant, is it good practice to have reverse DNS set for all allocated IP addresses? For instance, for a unique for unused IPv4 addresses, we set up a reverse record along the list for 29.4e1 c2b.static.domain.com.
Okay, in IPv6, I think even in IPv4, but at least in IPv6, because you have, it's much more flexible. What we can advise you is you can have, according to your IPAM, you can have some blocks, one related to your own infrastructure, let's say your backbone. And in your backbone, usually you will need at least one in your reverse zone file, the address of your SMTP server, or sometimes also for your point-to-point link. So you allocate a specific block for your own infrastructure, the reverse one, and for each customer that you have, or let's say each POP, depending on how you want to split it, you can decide to create a reverse delegation for some particular portion of your network, but you don't have to create for all your network. Let's say you have a /32, and maybe you have 1/36 for your core network, and you have /40, and you'll create various IP6.ARPA for each /40. And maybe within each /40, within each zone file related to this /40, you just have to create one or two links, because you know that, okay, this is my point-to-point for this section.
Okay, thank you, Willie. Joseph said he was late. Will he have the presentation documented? Yeah, we're going to share the presentation and the video, the recording. You have it. We're going to share at the end, and we will send you a link for the survey. When you fill the survey, you will get the documentation. Samuel is asking, what is the utility equivalent of zipcalc on Linux? So the zipcalc that really run is on Linux.
Yes.
So you can get the binary online and install it on your computer, and then there you go.
Yes, it's on Linux, so you don't have to. It's a Linux tool.
In fact, it's in the repositories. apt-get all of aptitude. It's easy to install from all Linux distributions. Yes. So it's the Windows guys for whom it's a bit more difficult. So.
Yes, for the Windows guys, you have to use some online tools on the internet. But for all who are using either Linux or Mac, you have zipcalc. Just apt-get zipcalc, you install zipcalc. So while we are here, I just want to show you something related to how everything is linked. Currently in your screen, what you have is a query. I want to know for this address, the name behind this address, okay? So I use dig-x and I put the number. And what is very specific here, I had this parameter trace, okay? So here is the output. First thing, remember that everything comes from the root. So first thing my resolver did is it goes in the root servers, because you want to know exactly for this number, where can I get the 2? Then one server here respond. This one respond. Sorry, I'll just highlight it. This is the response, okay? From these servers, from this block, you have a response from one server. Then you'll have another one. We just go below. Notice that on the left, we were on the dot here. now we are behind IP6.ARPA. And from IP6.ARPA, one server reply, this one reply. Okay. And it gives us the name of the name server for this block. So now we have 200142. Then from here we have, from this name server, we have then the zone file related to my number, and this is the answer. So you see, we start from the root servers. From the root servers, there is a link to IP6.ARPA. Then there is a link to something behind IP6.ARPA, which is an IPv6 block managed by AFRINIC. And then the link from AFRINIC to your own zone file is at the last step. And the links come from the delegation you create from my AFRINIC. Okay.
Okay, thank you, Willie. Next question is from Jeff Brown. He says, thank you for the whois H whois at FingerNet 2C0FFC E8 4801/64. But if our DNS has been delegated by the hosting provider, how can you find the name of the servers that they have delegated to?
If you have you can find the name of the server from the domain object. When you query the database, you will see among the attributes, you have one, if you have it in the,
so
yes, is it written somewhere? I can find it. Where is it?
Where the Q&A, click on
Q&A, okay, in Q&A. Okay, just let me go quickly on the Q&A and I'll be able to see. Okay. Okay, we do it together, just quickly. Okay.
I notice that you forgot the -D, so you just query the.
Yes, so just okay. So from your, okay, this is what we will do. Okay, -T. This is the block. I just put this one. Okay, so I will also add -B, capital B. Okay, for your question, here are the name servers. For your questions, the name servers are here. And the query was, here are the parameter, -R, because I don't want to all the details, and capital B, D, and your IPv6 block. And then you have your answer here. I hope it's clear now.
Yeah. Okay, thank you, Willie. So R is to disable recursive search. B is to return the entire block, that is without it being filtered. And the D is for domain. Thank you. Okay, another question from Landry Kojo. Is it advisable to migrate our DNS infrastructure to IPv6 before configuring DNSSEC or doing the reverse?
You can do DNSSEC later. If you are not already start DNSSEC, you can do DNSSEC later.
Okay, thank you. So yeah, you don't migrate. You don't want to migrate your DNS server on IPv6. You want to, get both IPv6 and IPv4, so that if requests are coming from IPv4, you should be able to resolve them. So it's not like you're migrating. Okay. Any other question, please type in the Q&A, raise your hand, type in the chat. We'll get to you.
Okay.
Well.
I hope the presentation was good for you, so, and you understand how the purpose of IPv6, the reverse zone, and you see that it's not very difficult, at least the DNS part, when we talk about the IPv6 challenge. Oh, what is the whois equivalent on the whois website? Okay. Let's go on to whois into my AFRINIC. Okay, from here, I think I still have this address by default, but I have to,
Flags.
Yes, I have to tick some flags, the one related to domain. I tick domain.
Flags.
Okay, so I tick domain. I click on search again. Okay, sorry, there were, okay. Just want to add. Okay, and okay. Okay, so here's the answer from the website. So basically, what you should do is you type your IPv6 address, you go on flags, you tick on the relevant object type, you go on flags, you tick the relevant flags here, and for the domain, for the domain object, you also have to prepend it at the beginning. So after that, you have the answer at the bottom.
Good, thank you, Willie. Any other question? No question. So